All right. So now it's recording and now I can post this on Moodle for your class. And then I teach 2 online sections as well. And they've been asking if I can post it too. All right. So chapters 2 and 3 notes, I was hoping that y'all went through those so we can just start hitting the homework instead of going through the slideshows. Because they're pretty long and it'd be pretty time consuming, and I think it's a bigger benefit in just going over some homework questions. That being said, did anyone see anything from the notes that they want to review? Negative? All right, let's see. I'm gonna share my screen again. And then, all right, so everyone could see my open math up there. Right. One person, you mean? Okay, good. Thank you. All right. So this is the week 2 stuff. So the slides for the chapter 2 notes. Remember, I'm going to start just putting the slides into Moodle because that's where you can download them and print them. For some reason, you can't download and print them in My Open Math. But so the prep assignment, did you have any questions from the prep assignment for chapter 2? So you can see that I'm doing the homework along with you. So that should have been pretty straightforward because you can just change your answer if you get it wrong on these true false, and then they give you they mark you right. Okay, so no questions on that. So the way we'll play it here is because I'm recording, I'll go through a bunch of problems that I think are beneficial for y'all to see, and then I can stop the recording, and then you all can work on homework yourself if you want to stay, and then ask me questions as they come up. All right. So back to chapter 2A homework. So let's start by going over a few of these. So basically number 1, and I don't know if you want to have your assignment open at the same time or if you just want to kind of watch me, but this thing's called a stem and leaf plot, this first one. And basically the way it's working, it shows house sale price over the last week at Tacoma. What's the most expensive house sold? So the first number results the number of 100,000s. And then the number over here represents the 10,000s. Like, so if you take the 0 and one of these 9s up here, that means that home's worth 90,000. So that's probably kind of a fictitious number in this day and age. But the most expensive house is going to be with the 3 and the 4. So it's 300,000 and then 4 10,000s. So it would be $340,000. So that's kind of the way you read a stem and leaf plot. And then, so we got a 5-number summary. The 5-number summary, remember, is the 5-number summary is the minimum value, right? So min stands for minimum. Now my stinking pen is not going to work right. Might have too many programs open on this poor little MacBook. That doesn't want to work at all. That's grand. Okay, min, and then this is the first. Okay, this is going to be ridiculous, but Q1 stands for first quartile, and first quartile is basically 25%. It's like between 0 and 25%. So if we look at this and you look at how many values we have, there's 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 values in this set of data. So the way you'd read it is 14 would be the lowest data value. Then you got 15, and then 25, and then 26, and then 29, etc. So what do we say? 18 values. So the lowest value is 14. So we could get that one thrown in there real quick. 14. The highest value is 67. The middle value is going to be, because we have 18 values, it's going to be halfway between the 8th and 9th value. So let's see, 1, 2, 3, 4, 5, 6, 7. I mean, the 9th and 10th value is going to be halfway between the 9th and 10th. So 43 is the 9th value. Unfortunately, oh, I don't have my. Okay. I'm malfunctioning here. This is going to be a terrible video. So my 9th value, right, is going to be well, 1, 2, 3, 4, 5, 6, 7. 43 is my 9th value. $43 is my 9th, and 47 is my 10th. So the median is going to be halfway between those. So the median is going to be 45. And that's what you're going to put right here. Then, since the bottom half of the data has 9 values and the top half of the data has 9 values, the middle value is going to be the 5th from the bottom. So 14, 15, 25, 26, 29. The 5th value is going to represent quartile 1, and the 5th from the top will represent quartile 3. So 67, 60, 56, 53, 51 is going to be quartile 3. Now let's hope those are all correct. And they are. Montserrat, is that what you go by?
Yeah, I go by Monse.
Monse. Okay,
Yeah.
go ahead.
So would it be the same thing if it had like 0, like for the 40, 43, 47? Would the 0 still count in when you're trying to do the middle number?
Yeah, 40 is going to end up being, let's see, 1, 2, 3, 4, 5, 6. 40 is going to be the 8th value, right?
Yeah.
If you missed them. Yeah, so 40 you would definitely have to count. Yep.
Okay, thank you.
Okay, what other questions from that one before we move along? I don't think we're going to have time to do every single problem, but that's just how quartiles work. So what other questions from that one? All right, so let's see. We'll go on and take a look at the next one. That was just reading a bar graph, right? So data was collected, or a histogram, I should say. This is the histogram because it's a frequency. Which statement best describes the meaning of one of the bars in the histogram? So let's see, 210 snacks have between 200 and 220. That wouldn't be right because the number of snacks is over here on the left, right? 210 snacks have 11 grams of sugar. That's probably going to be the winner because halfway between 200 and 220 is 210. And there's 11 of them that have that many milligrams of sugar. And then 11 snacks have about 210 Oh, I'm wrong. I'm totally off. It's this one I meant to check. 11 snacks have about 210 milligrams of sugar. The largest number of snacks have 11 milligrams of sugar. No, the largest number of snacks have about 210 milligrams of sugar. So there we go. All right. This one's kind of I'll get you started on this one, and I'm not gonna, but all you would do for this one, they want you to put the classes of numbers like 4 apart. So this next one is going to be 90 to 94. and then the next one would be 95 to 99, and you just keep tracking it down like that. And then how many students got between an 85 and an 89 on their IQ? So then you would just count how many between 85 and 89. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it looks like. And then you put that frequency there. And you just keep going, and you would do that for the whole table. All right, so we won't take class time up for doing that. Unless you have questions on that one. What do you think? We're good on that one. And then you just look down here at which is the correct histogram and pick the right one. There's going to be 1, 2, 3, 4, 5, 6, 7. There should be 7 bars because we have 7 classes. So anything with less than 7 bars is going to get disqualified. So it's basically got to be the third, this one down here, doesn't it? Because that's the only one with 7 bars. Did we get it? Yeah. Okay. Moving right along. Now this one, I don't know. Let's see if my annotator works any better. But there's a formula for the kth percentile. So the formula for the kth percentile looks like this. K equals, and this is the position of that number. And you take, oh, I should say the ith percentile. I wrote the formulas down. Now I'm getting confusing myself. So what position is going to be, is that 45th percentile going to be in? Well, we're going to put 45 in for K, and then we take the number of values for N. So we're going to put 45 in right there, and we're going to put 117 in right there, and you're going to make the calculation. So let's see what we get for that calculation. Okay, so that calculation going to be 45 over 100 times 118, right? Because we put 117 in for N, so times 118. So this 45th percentile is going to be in about the 53rd position. So let's see if it works. The 45th percentile. So in other words, 45% of the data is going to be less than the number that we're about to put in. And it's in the 53rd position in this list. So let's see how many are in each row. Are there 9 in each row? So 9, 18, 27, 36, 45. What did I say it was again? The 53rd position. So 1, 2, 3, 4, 5. So this is 46, 47, 48, 49, 50, 51, 52, 53. So it should be 48.7. Let's see if we get it right. 48.7. Nope. Wrong. 53rd position, right? It's 53.1. So I wonder if it's between the 53rd and the 54th. So between the 53rd and the 54th is going to be 48.7 and 48.9. So halfway in between them is 48.8. Yeah, so if you get a decimal, then you're going to have to go halfway in between the values. All righty, so I went halfway between the 53rd and 54th value to get that 45th percentile. That one's kind of confusing, but this formula here gives the position. So this is the position of the wanted percentile. So position of, in our case, 45th percentile. So What questions from that one?
So would you basically, since it was 53.1, would you count down by 5 and then count 3 horizontally to get the number?
Well, because each row has 9 values, right?
Yeah.
So I went 9, 18, 27, 36, 45. So that right there is the 46th value, the one I circled. So 46, 47, 48, 49, 50, 51, 52, 53.
Oh, okay.
So that's the 53rd and 54th value right there.
Oh, okay. I was getting that mixed up.
Yeah, so I just took halfway in between those two. Does the fan on my computer sound really loud on your end?
No.
No, okay. Good. It's really loud on my end for some reason. All right. Would it be worth doing one more of those?
Yes, that'd be
Okay.
great.
So let's look at the next one down then, number 6. We want the 74th percentile here, 74th percentile from this data. So this data's got 5, 10, 15, 20, 25 data points, right? So that data, the N is 25, and you want P74. So I is going to be 74 over 100 times 25 plus 1. And that's going to give you the position you're looking for. So let's see what position that's going to be in. 74 over 100. 25 plus 1 is 26. So let's just do that. So I'm like looking between the 19th and 20th positions. All right, so that just tells you this formula gives you what position in the list you're looking for. So I'm looking between the 19th and 20th. So 5, 10, 15, 16, 17, 18, 19 is going to be this value right there. And the 20th would be that value right there. So in theory, halfway between those numbers should be correct. So 67 should be correct.
How did you know to use the 25?
Because I count up the number of items in the whole set of data. So there's
Okay.
5 in each row and there's 5 rows. So right, there's 25 then. There's 25 numbers in that table.
Okay, perfect. Thank you.
Mm-hmm. Would it be worth doing one more? Probably, right? Okay. Let's go down to do number 7 then. They want the 25th, 50th, and 75th from the set of 33 data. Well, we could find the 50th pretty easy. The 50th is going to be the halfway point. So halfway between the first data point and the 33rd data point is 17, right? 17 is going to be the halfway point. So if we go to the 17th data item, so they're listed in order, thankfully, 5, 10, 15, 16, 17 is 52. So that's going to be the 50th percentile is 52. And now I know that there's 16 data values below and 16 data values above. So basically halfway between the 8th and 9th, going either way, is going to give you those quartiles. So we go up to the 8th and 9th values in the list. The 8th and 9th values in the list here are going to be 24 and 28. So that gives you the 25th percentile is going to be 26, which is halfway between those two. And then 75th, we count backwards. between the 9th and the 10th. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Halfway between the 9th and the 10th going backwards. It's going to be halfway in between those two. So you can find the average of those two numbers. I think it's going to be 67.5 then. It's halfway in between those two. Let's see. Oh, that's wrong. Huh. Let's see. Let's use the formula then to do the 75th percentile. So we do 33 or 75 over 100 times 33 plus 1. So that's going to give us the position of the 75th percentile. Let's see what we get. 75 over 100 times 34. So the 25.5. So halfway between the 25th and 26th data points. So I must have counted wrong. Let's see, halfway between the 25th and 26th. So 5, 10, 15, 20, 25 is going to be that data point then. And the 26th is going to be that one. So obviously I counted incorrectly. Luckily, we have a second try on this. So halfway between those two is going to be 75. And there we go. So we kind of showed it with the formula and with just counting it. All right, what questions do y'all have before we leave core percentiles? And let's see. No one has posted anything in the chat. Okay. So let's see, this is another one where you're just, oh, this one's tricky. This would be beneficial for everyone to see. The drawing the bar graph is really tricky. So first things first, we got to do the frequency distribution. So we need to figure out how many scores are between these numbers. So between 40 and 49, they have them in ascending, kind of ascending order for us. So 1, 2, 3, 4, 5, 6 scores between 40 and 49, and then one score between 50 and 59. You all have different numbers probably. 1, 2, 3, 4 between 60 and 69. 1, 2, 3, 4, 5, 6 between 70 and 79. 1, 2, 3, 4, 5 between 80 and 89, and then 2. Let's make sure those are all right before I go on. So I just hit the enter button to make sure they're all right. And it probably takes a try away from me. Yeah, takes a try away from me, but that's all right. I want to check that before I draw the bars. So here's how we draw the bars. The line segment thing is clicked already, so that's good. Between 40 and 50, my frequency is 6. So I go up here and you're going to see a little pencil tool. And I'm going to go up and draw a little horizontal line on 6. And then I would draw a vertical line up from 40 and draw and to do the left side of that bar. All right, now instead of drawing, because actually you could probably just go ahead and draw that right now. So there you go. There's our first bar. The second bar of the frequency is 1. So I'm going to draw that right there at 1. And then draw, actually, I'm going to wait on that one. And you'll see why I got a method to my madness here. Between, see what happened there? Between 60 and 69, I have 4. So I'll draw a little horizontal line right there. And now the reason I waited on this little segment here is so I could just draw the whole thing at once. All right, and then 70 to 79 is 6. So I'll draw a little horizontal line right there. And then boom, draw that one. 80 to 89 is 5. Little horizontal line right there. Throw that vertical line. Whoops, I went too far. And then 90 to 99 is 2. So then we draw the vertical bars right there. And there we have it. So I was able to draw a histogram. What do you think, everyone? That one looking good? So the table part of it's not difficult, but then drawing the bar graph, anytime you got to draw a graph in my open math, it gets kind of tricky. Okay, your silence indicates you want to move on. So here we go. Oh, so this is called a box and whisker plot. A box and whisker. All right, so basically what's happening here, and I can kind of talk about it as we go in here. This value here, 6 is going to be the minimum value. 10 is going to be the first quartile. So that means 25% of the data lies in between 6 and 10. 19 is the median. 25% of the data lies between 10 and 19. 21 is the third quartile. So 25% of the data lies in between those two values. And then the max is 26, and 25% of the data lies in between those two values. So what has the smallest spread? Which quarter has the smallest spread? Well, it looks like the third quarter has only a 2. The range is only 2. So the third, what is that spread? 2. Which quarter has the largest spread? Well, it looks like between Q1 and the median, you could look at that as the second quartile, right? Between Q1 and the median, that would be the second quarter. What is that spread between 10 and 19? That spread is 9. The interquartile range that they're referring to, this IQR number, that stands for interquartile range, is basically Q3 minus Q1. So you take 21 minus 10. So the interquartile range here is going to be 11. Now the last one's tricky. Which interval has the most data in it? So 10 to 18 probably doesn't have 25% of the data in it. 19 to 22 is actually going to have more than 25% of the data in it, because 19 to 21 contains 25%. 19 to 22 is going to contain more than 25%. 6 to 10, that contains 25%. So far our winner is that one, 19 to 22. Then 21 to 26 contains 25%. So 19 to 22 is going to contain more than 25%. So that has the most data in it. And what value could represent the 52nd percentile? So the 52nd percentile, the 50th percentile is going to be 19. So 52nd has to be somewhere between 19 and 21. So then we can go down and just select that number. That's probably 20 then. That's 19 to 21. So submit all parts. Hey, we got it all right. Wow, that one's worth 7 points. All right, let me pause for a second, see if you have any questions on that one. What do you think? So that went pretty quickly.
When you're doing the box plot, would it always stay 25 on each one?
Yeah, on that. See, it's a box and whisker. So the whiskers are on the outside. 25% of the data happens within that first whisker, and then 25% in the last. Like we could have done that. We could have done a box and whisker for all those sets of data that we went up above. And then basically you put the 5-number summary just goes on that. Does that answer your question?
Yeah, thank you.
Okay. Any others from that one? So even though that's not really calculation intensive, it's just tricky. And hit the hint down here anytime. It probably just brings you to the chapter, unfortunately. Oh no, there you go. It gave us a hint here. So I like it. All right, let's see what else we got here. Question 10. They want to know which is true. I think I'm going to skip that one and y'all can take a look at that one and try to figure it out. 11 compares two different data sets. Box plot shows the salaries for CPAs. A CPA is an accountant, right? An actuary is like a insurance bigwig. Before I went into teaching, I was studying to be an actuary. That show The Office, that was going to be my future. So I decided to teach instead. All right. If a person is making the maximum salary for a CPA, so the maximum salary is going to be, can you all see my arrow when I'm circling? Maybe I'll just draw it. Here we go. Maximum salary for a CPA is represented by that vertical bar right there. So the maximum salary for a CPA is just to the right of $90,000. So a person making the maximum salary of a CPA is equivalent to, let's see what our options are. The what for the salary for an actuary. So it looks like the third quartile salary for an actuary, right? Third quartile. And he's making less than 25% of actuaries, right? Because 25% of the actuaries make more than that 92,000 or whatever it is. All right, so that's the way you would read that problem. What do you think? What questions do we have from that one?
For mine, it says that the third quartile salary, instead of maximum, it says third quartile. So how would we do that if it was in that sense?
Can you share your screen, Monse, and we'll take a look?
Yeah.
And this mean everyone that sees this, that watches this video, it'll help them too. So this is good. So there's a little green button down the bottom, and then you could just select, when it pops up, you can select the window that you have your assignment open in.
Okay. Sorry, it's taking me a while.
That's okay. Or should I see if I can find if I select a different version, maybe I'll find yours.
Yeah, for some reason it's not. Oh, never mind. I think
Oh, you got it?
it's not letting me record my screen, but I think it might let me know.
So
Oh.
when you, oh, do you see it?
Yeah, I found
The share screen. Oh, there we go.
yeah, this is
Perfect.
mine.
So a person is making the third quartile salary as a CPA. So that's going to be, let me see, where's my annotate? Third quartile is going to be about right there for a CPA, right?
Yeah.
So the third quartile for a CPA is about at the median for an actuary, isn't it? Because they're about the same.
Yeah.
So your answer is going to be median for that one.
Okay.
And then and he is making less than what percent of actuaries then? So this many actuaries make more than that CPA. And that number of actuaries is 50%, right?
Yeah.
Yeah, there we go.
Okay. Thank you.
Yep. Okie dokie. Let's look at what we got going here. So this one, all right, y'all can do that one. You just figure out which quarter each one's in. I'll let you do a little struggle with that one. All right, 5-number summary. Okay, so here's where we get into the graphing calculator, everybody. And so this is why a graphing calculator is required for this class. Like I was telling, or what I put in my message to you at the beginning of the quarter, or beginning of the term. Do we call them quarters, or I think they're called quarters, aren't they? Maybe terms. I don't know, but anyway, what you got to do is you could go to St. Vinny's or Goodwill. A lot of times they'll have the TI-83 or TI-84 calculators, or I think they're like $100 now at Walmart or Target or something like that. I downloaded something on my MacBook here, and it's a 90-day free trial version. So that's another thing to do, is look for this TI Smart View, and you can put it on your computer. Since you need to have your computer open anyway for the test, it's totally legal to use. So I just got a 90-day free trial version of this. So that's another option if you're looking around for calculators. But you definitely need one, right? There's kind of no way around it. So that being said, let's look at this set of data. There's 11 data in it, and they want to figure out the 5-number summary. We could actually do this by hand, but this is as good a time as any to look at the calculator. So what you would do in this problem is you're going to hit the stat button. So the stat button is right there, and you're going to hit the very first option, which is edit. And then when you do that, you're going to see these lists pop up. Well, if you have something in your lists like I do, you go up to the top by hitting the up button, and then you hit clear, enter. And when you go up and select the list, see how it's darkened up there? Clear, enter. And that is going to clear out your list. Now what I'm going to do is I'm going to put those 11 values into the list. So 8, and then you can just type them in and hit the down arrow, and you will see your list go in there. So all I'm doing is I'm typing that list in. So there you go. Now I have that list in there. Now I want the 5-number summary. Okay. I want the 5-number summary using that list. So the 5-number summary basically is the min, first quartile, median, third quartile, max. So then I'm going to go to stat again. I hit stat, and I'm going to go over to calc. Go to calc, and I want one variable statistics. So one var stats, hit enter, and then my list is going to be L1. I don't have a frequency list in this case. We're going to deal with those later. So I'm going to leave that blank, and then I go down to calculate, and while it's blinking there, I hit enter, and you're going to see a bunch of stuff on there, and you're like, what does all that mean? Well, we're going to know what it means probably by the end of this period or class, whatever. I'm a high school teacher too, so I call it a period. Okay, so here we go. Our 5-number summary is right there. Min, Q1, median, Q3, and max. So I just put those numbers in. Now, unfortunately, when I click on my open math, the calculator goes away, but there we go. All right, so here we go. Then I just put those in, right? 11, no, that's wrong. 8, 21, 66, 77, 87. So there's my 5-number summary. And that works for any set of data. All right, any set of data that's going to work for. Would it be worth seeing one more of those? Yep. Okay, so let's take a look at the next one then. The next set of data right here. And we definitely have to do 15. The next set of data, here we go. I go to edit again. I want to clear that out, right? So what do I do to clear it out? I go up and go clear, enter, and now it's gone. And then I just start typing the data values. So 141, 175, 185, 201, and just keep on entering them. Now, let it be known that if you get a single one of these wrong, like if you mistype a single one of these, it could mess a lot of things up. So don't get discouraged if you type something in to My Open Math and it's wrong. There's a chance that you may have missed a number or you just typed one in incorrectly. So go back and check your list and make sure that everything's entered correctly. So let's see, hopefully that's correct. The next step, I hit stat again, over to calc. I got 1 var stats, enter, frequency list L1, I mean list L1, don't have a frequency list, calculate, and there we go. There's going to be my 5-number summary starting with min X right there. And just go to My Open Math, type them in. You notice that the median is a decimal because there must have been halfway between 2 other data values. 720. Watch, I probably typed one of them wrong and I'm going to get up. There we go. So I must have typed one of them wrong, right? Anyone see which one? So 141, 175, 185, 201, 265, 310, 337, 592, 712. All right, it's not liking that. I wonder what happened. Those are all correct. So there's 14 values. So most of the 4th value is actually going to be my yeah, I'm not sure why this is huh. Yep, that's something. I'm sticking by my answers. Because the bottom set of data's got 7, the top set of data's got 7. So Q3 should be the 4th up. I wonder what their answers are. Let's see. I gotta run myself out of try so I can see what the answers are. That's not letting me see the answers. I'm sticking with my answers, everybody. So if you run into problems on this one and you get them wrong, just give me a shout out and I can override it and give you credit for that. Alrighty. Those of you that are with me, do you see something I did wrong? Because we double checked the data. I know there's 14 data points. So there we go. I wouldn't think that this has got to be 716, is it? No. Yeah, I'm not sure what happened. What about 724? 724, huh? Yeah, I think this problem's incorrectly written. There you go. So we're going to run into problems with 14. Just give me a shout out and let me know. All right. 5-number summary of a data set was found to be this right here. We got to talk about outliers. So outliers are going to be numbers that aren't typical to that set of data. So there's a formula for the outliers. So here's what the formula looks like. What you do, and you basically have to do 1.5. You take Q1 minus 1.5 times the interquartile range, and any number below that is considered to be an outlier. All right, so Q1 in this case is 52, right? 5-number summary, that's Q1, and 63 is Q3. So if I do 52 minus 1.5 times 9, interquartile range, oh, it's 11. Interquartile range is 11 here, right? IQR equals 11. Okay, so if I did 52 minus 1.5 times 11, and anything less than that number is considered to be an outlier. So 52, well, I got to get out of that. I got to go back to my regular work screen here. 52 minus 1.5 times 11. So any number less than 35.5 is going to be considered to be an outlier. Okay, so that's, in other words, that's going to be an atypical data value. And then anything greater than Q3 plus 1.5 IQR. So if I do Q3 plus 1.5 times the IQR, anything above that number is considered to be an outlier. In other words, an atypical data value. So I think that's going to be 68.5 if I'm not mistaken. Let's see how good my mental math is. Not very good. Oh, 1.5 times 11, 79.5. Holy smokes. Here we go. I did 63 plus half of 11. Okay. That's it with that section then. What questions y'all have before we track to the next section? Class ends at 6:20. I'm probably gonna have to get going a little quicker here, huh?
So how did you find the IQR again for this, for number 15?
So I subtract that's 63 minus 52. Remember, because the IQR is Q3 minus Q1.
Oh, okay.
Yeah, Q3 minus Q1 is my IQR. So 63 minus 52. Yeah, if anyone that watches this video figures out what the heck if I did something wrong on the last one, I don't think I did, but if I did, give me a shout out and let me know what I did wrong. And I could tell the whole class. All right, what else from that one? All right. So let's go to, unfortunately, week 2 ended up being a long week. as far as homework went. Right, because aren't there's like 3 homework assignments from week 2. Right, it's 2A, 2B, and 3A. Next week, luckily, there's only 2 assignments, right? The 3B and the chapter 4. Okay, chapter 4, we get into some stats, some heavier stats. Okay, here we go. Chapter 2B. What if I do a teacher preview? I can look at the answers then. Let's do that. All right. So the data is from a sample. Calculate the mean, standard deviation, and variance. Okay. So, you know, we could do it by hand, and Wendy she describes how to do it by hand in her videos. So let me show you what it looks like on the calculator instead, because you know this course is very calculator intensive. So if we look at it on the calculator instead, you're going to enter that data set the same exact way that you entered the data set before. Oh, I got a chat question. Yeah, it's not, it's a good question, Estelle. So they are graded, they count for a lot less. You'll see that they're like between 8 and 13 points each, something like that. But yeah, they do count for a grade, which is kind of good because they're much easier than the regular assignments. Yeah, good question. All right, so let's go to edit our list, clear, enter. I want to put that list in same as I did, right? 10.8, 44.2, 43.8, 43.1, 26.5, 14.8, 12.3, 35.4, and 49.5. So there we go. I got my 9 data values entered. Same process. You're gonna go stat, edit, nope, stat, calc, and you want 1 bar stats again. So hit that one, list L1, yup, frequency list, no frequency list, calculate, boom, here we go. So X bar is going to be the mean. All right, it's the mean and the sample mean. So they want 2 decimal places. So we're going to put 31.16. Okay, then it wants the sample standard deviation. So the sample standard deviation is going to be which one is it? Let's see. I better look at my notes. The sample standard deviation is going to be S. So the S value, that's your sample, 15.36 is going to be the sample standard deviation. The sample variance is the square of the standard deviation. So I would actually have to calculate 15.36 squared. And I'm not sure why the heck they would ask that, truthfully. But 15.36 squared, that's actually going to be our variance. So 235.93. And please round to what they say to round to, because otherwise you may get it wrong. All right, so I got to go back to the stat calc again. Same thing. The sigma button here, this is lowercase sigma, is going to be that Greek letter. That's actually your population standard deviation. So if this data set was taken from an entire population, that would be the standard deviation instead. So 14.48. The sample standard deviation is going to be higher because it's assumed there could be more variance in a sample than there is in the whole population. So the population standard deviation will be lower. Okay, what do we have? What questions on number one? Number two, you're actually you would do the same exact calculations. The range is just gonna be the high minus the low, so the range would be 60 in this one. All right, so then you can answer all of those questions, same way I just answered that one. All right, throw them into the graphing calculator, do the 1var stats, and then just answer all the questions. Should we? Okay. Yes, I think you can do that one. Let's look at 3, because 3 asks for a couple of different things than we've been doing. Y'all can see my MyOpenMathing calculator side by side, right? I hope. Good. All right. So the highway mileage for a sample of 9 different models of a car company can be found below. Find the mode. The mode is the data that happens the most. So it's the data point that happens the most. So you look at this, it looks like 42 happens twice, right? So that is going to be 42. And then they give you a couple hints down here. The mid-range is the average of the smallest and largest values. That's going to be the mid-range, the average between the smallest and largest. So what might be beneficial in our problem is to order these from smallest to largest. So 21 is the smallest. Let's see what the next one is. 24, then 26. And then 38. 39. 42. 42 and 43. Right, I think those are our 9 data values. I missed one, didn't I? 21, 24, 26. I missed 40. So 40 should be in there. So there we go. Squeeze it in. Mid-range is going to be halfway between the highest and lowest values. So the highest is 43, the lowest is 21. So halfway in between those two, let's see, they differ by what? 22. So it'd be 11 down from 43 or 11 up from, so I got to divide that by 2. 11 down from 43 or 11 up from 21. So the mid-range is going to be 32. Okay, then let's see, find the range. The range is the high number minus the low number. So that's going to be 22, high minus low, 43 minus 21 is 22. Standard deviation using the range rule of thumb. The range rule of thumb right down here says that the range is about 4 times the standard deviation. So range is 4 times the standard deviation. So I divide both sides by 4 and I get 22 fourths. What's that? 5.5. So the standard deviation using the rule of thumb is 5.5. And then now use technology to find the standard deviation. So then I go back to my calculator and I put all those in. Let's see, stat, edit, clear, enter, throw them in, right? 39, 24, 26, 42, 43, 42, 21, 40, and 38. And then I go over here, stat, calculate, one bar stats, enter, enter, enter. And then my standard deviation for this sample is 8.73. Is it 1 to 2 decimal places? There you go. So the estimate's not very good, the 5.5. But so that's the way you'd run through that one. What questions from that one? Okay. So the next one, which is more affected by extreme observations, the mean or the median? I'll let you think about that one and come up with it. You get 5 tries for a question, so if you can't get that one, that's a struggle. All right, adult men have a heights with a mean of 69 inches and a standard deviation of 2.8 inches. Find the height of a man with a z-score of 0.5357. We're going to talk a lot about the normal distribution in this class, but you got a formula here that says this. You have a formula that says the z-score for a person, you know, for any type of situation is going to be whatever their height is. And then you got the mean height over the standard deviation. Okay, so this is going to be the formula, and I'm using the population mean and the population standard deviation because that's what it's implying by adult men have heights. So now I got a z-score of 0.5357. I want to know that person's height, which is x. I got a mu of 69. That is going to be the average height. And then I got a median or a standard deviation of 2.8. So now what I can do is I can cross multiply here. And I could do 0.5357 times 2.8. And I have 1.49996. And then I'd have to add 69 to that. And I multiplied by 69. 1.49996 plus 69. So 70. Basically, if I round it to the nearest 4 decimal places, it's going to be 70.50000. All righty. So basically you're setting it up and you're just solving an equation. But this formula here, that formula is what you're going to use to do these ones with z-scores. Okay. What do you think? Questions? Did we lose somebody? Looks like we lost somebody. Okay. All right, so I'm going to let y'all struggle with number 6. I think we're going to be good. You can figure that out. Find the measures of center for the following. So this one is an interesting little problem. We have data values and we want to use the center point of each of these data values. So it's kind of like you're not looking at 30 to 34. You're kind of considering that 32 happens 10 times. 37 happens 20 times. 42 happens 11 times. So what happens the most? 37, because 37 is halfway between 35 and 39. So the mode for this set of data is 37. Now the median is a little trickier. We got to add up all of the frequencies. So 10, that's 30, 41, 52, 57, 60, 64, 65, 67 data values. So half of 67 is 33.5. So the 34th data value is going to be the median. 34th data value is the median. So these are tricky, but once you get it, it's not bad. So we have 10 data values from 30 to 34, and then another 20 from 35 to 39. So now there's 30 data values that are 39 or less. Then the next 11, so 31st, 32nd, 33rd, 34th, the 34th data value then is going to be 42. So that's what we're going to put right here. Median is 42. The mean is going to be the average. So let's figure out how to do this kind of chart in our calculator. All righty. So first of all, the data has to be the 40, the 32, 37, 42, 47. So when I go to stat and I go to edit, now I'm going to go up here, I'm going to hit clear, enter. Now I'm going to enter those data values, 32, because that's halfway between 30 and 34, then 37, then 42, 47, 52, 57, 62, 67, and 72. Now on L2, I'm going to enter the frequencies. So I'm going to enter 10. 32 happens 10 times. 37 happens 20 times. And I enter all the frequencies. And now I'm going to calculate the same way I calculated before. So I go stat, calculate. I still want one var stats. This time, however, I have a frequency list. So when I pop down the freak list right there, I got to put L2. That column was L2. So I go second, L2 is the 2. So second L2 is my frequency list. Now hit calculate. And there you go. It gives you all the data. Hopefully it shows it's at the median's 42, right? There you go. Median's 42, like we thought it was going to be. All right. The mean is going to be that X bar up there. So the mean's going to be 43.7164. All righty. So that's how you're going to butter up that problem. What do you think? Questions on that one? All righty. What's this one all about? Stephen owed to his friend Eve. Oh, you guys figure that one out. That one's just common sense, right? We'll let you struggle with that a little bit. Let's take a look at the next one. Find the mean. So we would do the mean in number 9 exactly the way I did the mean in number 7. All right, enter that frequency, the left and the right in L1 and L2, and then do the one var stats. You want to see it real quick? Okay, let's do number 10. Number 9 works the same way as 10. So let's do 10 together. So I'm going to edit my tables. So I got to clear out both of them. So clear, enter. Let's go over to L1. Clear, enter. So now I go 0, 1, 2, 3, 4, 5. There's my left column. My frequencies are 2, 5, 3, 7, 6, 2. So basically it just wants mean, median, and mode. So then we go out to stat, calc, one var stats, frequency list L1. Now it's gonna keep L2 in there. So as you do your homework and you only have one list, you're gonna have to delete, right? You could go down here and hit the DEL button and it'll delete that off. All right, but we want it on for this one, so I'm gonna put it back in and then calculate. And there's my mean, 2.64. Uh-oh, they want 1 decimal, so I'll go 2.6. Median. The median we can run off of here too. The median is 3. The mode's the one that happens the most. The 1var stats on the calculator aren't going to tell us that. So the one that happens the most, the frequency is 7. You look at the highest frequency and the data value that corresponds to that is 3. So there's your mode. Okay. All right. Number 11, I'm going to let you think about that one. 12, we can let's see, which one should I? Let's do this one together, and then we're going to move on to chapter 3. Let's do this one. So 56 randomly selected students were asked the number of pairs of shoes they have. Let X represent the number of pairs of shoes. The results are as follows. So we are going to put this in just like we've put in the other sets. So we go over to stat, edit, clear, enter, up to the L1, clear, enter, and then just throw them in. So 4, 5, 6, 7, 8, 9, 10. So that's number of pairs of shoes. And then over to L2, 6 people own 4 pairs, 6 people own 5, 10 people own 6, 5, 11, 9, 9. All right, so there's my list. Going to stat, calc, 1var, L1's the list, the frequency list is L2, calculate, and we should be able to read a bunch of stuff off of here. So the mean, 4 decimal places. The mean, 7.2857. There's your mean. The median, I'm going to scroll down, find the median is 8. The sample standard deviation is the S sub X. So 1.9607 if I round. 1.9607. We get all those right? Excellent. First quartile. The beautiful thing about the 1var stats is it gives you all that stuff. First quartile is 6. Third quartile is 9. What percent of respondents have at least 4 pairs of shoes? All right, now we got to do some calculating, right? So we got to do some, how many respondents that have at least 4, well, all of them, right? All of them have at least 4 pairs of shoes. So it's 100%. 0% of all respondents have fewer than how many pairs of shoes? That's 4 again, isn't it? There you go. No one has fewer than 4 pairs. So that's why I put 4 there. Okay. What do you think? What questions on that section? Do we have a need to see any of the others here? I mean, that one is 13 and 14 are kind of multiple choice. 15, if you did the reading, shouldn't be too bad. And that one, I'm gonna let you do a little struggling with that one. Okay. All right, let's look at, thank you two for hanging out with me here. I'm gonna let's look at the next section then. So chapter 3A. How many points? Only 22 points. All right, we start with the probability section. All right, the probability section is fun. Here we go. Let's take a look at number 1. A special deck of cards has 6 red cards and 5 black cards. The red cards are numbered 1, 2, 3, 4, 5, 6, and the black cards are numbered 1, 2, 3, 4, 5. The cards are well shuffled and you randomly draw 1 card. So like, please watch the video and take the notes. All right. Then this section is going to make a lot more sense. But how many elements are in the sample space? There's 6 red and 5 black. So the number of elements is going to be 11. And then probability that event E happens. So the probability that a randomly drawn card is even. 3 red cards are even and 2 black cards are even. So 5 out of 11 black cards are even. So what we got to do then in our calculator is calculate 5 over 11. Unfortunately, they don't take fractions for some reason in this section. They want the decimals. So we would do 5 divided by 11. And they want you to round it to the nearest 4 decimal places, 2 decimals. So 0.45. Okay. So that would be the way that one runs. 2 is the same thing, same kind of problem. In fact, your number 1 might be my number 2, and vice versa. You never know. All right, what questions from those couple though? And this section has 13 questions. All right, so let's take a look at 3. A group of people were asked if life exists elsewhere in the galaxy. 261 responded yes, and 399 responded no. Find the probability that if a person is chosen at random, the person believes life exists elsewhere in the galaxy. So the first thing we should do is find out how many people responded to this survey. So the number of people that responded to this survey are going to be 261 and 399. So 660 total people. So the probability that you pick a person that believes, yes, there is life elsewhere, number of people who said yes, 261, total number of people surveyed, 660, and we get 0.3955 if we go out to the nearest 4 decimals. All righty, so that one's not too bad, I hope. All right. Next one's about a pair of dice, and they give you pictures. Isn't that nice? So 2 dice are rolled. What is the probability of getting a sum that equals 4? Well, the sum that equals 4 are going to be those 3 right there. The sum equals 4 on those 3 rolls. On the rest of the rolls, you get a number different than a 4. So therefore, the probability you roll a 4 is going to be 3 ways to roll a 4. There are 36 different rolls. So 3 out of 36, you go to your calculator. 3 out of 36. So 0.0833. Is what I get for mine. You probably have a different number. I think I've done this 3 times, it got 3 different sums. Okay. Card problem. As shown above, a classic deck of cards is made up of 52 cards, 26 black, 26 red. Each color split into 2 suits of 13 cards each. So clubs and spades are black, clubs is the top one, spades is the next one, and hearts and diamonds are red. Each suit is split into 13 individual cards, the ace, the 2 through 10, and the jack, queen, and king. Jacks, queens, and kings are considered face cards. All right. So if you select a card at random, what is the probability of getting a 3 of spades? There's only 1 3 of spades out of 52 cards. So that probability is going to be 1 over 52. So 0.0912, 0192. A club or a diamond. Well, what's the probability you get a club or a diamond? There's 26 clubs or diamonds out of 52 cards. So if they want me to round the nearest 4, I may have to put, actually, I think we could just put 0.5. Yeah. A number smaller than 3. We're counting the ace as a 1. So that's going to be 8 cards that are smaller than 3 out of 52. So go over here to my calculator, 8 over 52. 0.1538. All righty, so that's be the way we'd roll with card problems. Then we have some problems with tables. Well, there's only one with tables. A bunch of spinner problems, well, 2 with tables. Let's look at number 11. If one student is chosen at random, find the probability that the student did not get a B. So 23 students got B's. So 19 plus 34 did not get B's. So probability of not B. There's 19 plus 34 who didn't get a B over 76 total. So I think that's going to be what, 53 over 76, 4 decimal places again. And it looks like we get 0.6974. All righty. 12 works the same way as that one beforehand worked. The one we did with life somewhere else in the galaxy. 13 we're going to go over. Let's look at 13 in a minute. Any questions on 11 though? 11 looks good. All right. Let's go back to so 6 and 7 we kind of answered. So use the spinner below to find the probability of getting the following after one spin. So you want to find out the probability that the number is greater than 2. So there are 12 numbers altogether in the spinner. We're going to assume each number is equally likely to be landed on. So there are 10 numbers greater than 2, right? 3, 4, 5, 6, 7, all the way up to 12. There's 10 numbers greater than 2 out of 12. So I go to my calculator and I do that one, 10 over 12. 10 over 12. And we get 0.8333. And that's what I'm putting in there. Got to do it. Look, if I put 0.83, it marks me wrong. If I put 8333, bunch of 3s, oh, it gave it to me. There was a student asked me a question today about that. They put 0.166666 and it marked them wrong because they didn't round to the nearest 4th decimal place. So do what they say, or if and then if you get it wrong, make sure you round it to the nearest decimal. Just the moral of the story there. Okay. So the last problem we should go over is number 13. If U and V are mutually exclusive. Mutually exclusive means that they cannot happen at the same time. So let's write that down. Mutually exclusive. It means they cannot both happen. Right? Like, I cannot be both in Oregon and Connecticut. Right? The probability that I'm in both places is 0. Okay, so that's what I'm going to put here is probability of U and V is 0. Okay, probability of U, the next one down, is called conditional probability. Probability of U given V. So V has already happened. So what's the probability that U happens, given that V has already happened? The formula for that looks like this. Probability of U and V divided by the probability of V. So you look at that formula and you're like, well, I know that the top of that equals 0. So now this is going to be 0 divided by 0.52. You're like, okay, well, 0 divided by anything is 0, except 0 divided by 0, which is undefined. Okay, so that's got to be 0 as well. And then the other thing about mutually exclusive is that to find the probability that either or happens, so probability U or V, it's going to be probability of U plus probability of V. So that is going to be the formula if it's mutually exclusive. If they're not, we got to subtract off the probability that they both happen. All right. So that's basically going to be 0.7 then, because 0.18 and 0.52 equals 0.7. Okay. So that's, man, that's a real hard look at all 3 of those homework sections, but luckily now they'll be posted onto my well, I'll put them on Moodle. I'll put this recording on Moodle so people will be able to go back and look. But Monse and Estelle, do you have any other questions? Like, we could go back, we can hang out, the 3 of us, and you can ask me any questions you have from your assignment if you want. I'm going to stop the recording now, if I could figure out how. Let's see, let's stop share for a minute. And then stop recording. There we go.